are going to wrap up. Not really at the end of chapter 3, that would be a lie. There's so much more to come in chapter 3. These calc chapters go on forever and a day. But where we are going to end before Christmas, most likely with this. So,
what was that most likely for?
Yeah, this will be because the next section is more than I can get through and have final review time. So plan is tentatively, we do this section today. I give you a study guide and a work day Monday. We go over the study guide Tuesday, test Wednesday over just this last little bit, which hasn't actually been that much. So it's not a full test, it's a shorter one. All of the implicit differentiation stuff that we've been doing. So think of it as a long quiz more than a test probably. But
Did we already take the test where it's like...
We have chain rule and implicit differentiation on this. We did a test over basic derivatives, product, and quotient rule already. So it's sections 4, 5, and 6 on this one. Then after that, we'll start preparing for our final. So. All right, let's figure this out.
Derivative of log AX.
So if I'm trying to figure this out, log base A of x is equal to, let's just say y. Okay.
Oh, so a to the y equals x.
Definition of logs, if we write it as an exponential, a to the y equals x. And we can do the derivative of this. We said a number to a power is still a number to the power. But if the base isn't a, or isn't e, you have to take it times the natural log of the base, so times the natural log of a.
Times the derivative of the exponent of x.
Since y prime or dy dx equals 1. So if I'm solving for dy dx,
Just divide that down.
it's 1 over a to y natural log of a.
Oh, are these going to be formulas too?
And from earlier in the problem, a to the y is equal to,
X. What?
so
Substitution.
dy dx is 1 over x natural log a. So x is the argument, so it's 1 over the argument times the natural log of the base. That is now something that we can use as fact. However, this is kind of cumbersome. Just like with exponentials, we preferred e's, right? Because they had a nice derivative. The same is true with logs. If you have a natural log, that is much nicer. Because if I'm doing this derivative, it's 1 over the argument times the natural log of the base. Natural log, the base of a natural log is e. What is the natural log of e? So it turns into 1 over x. So we may encounter logs every now and then, but for the most part it's going to be a natural log. And the derivative of a natural log is just 1 over the argument. So that is really the big result that we are using. And of course chain rule would still apply, so if this is not just a plain x right here, we would have to do the chain rule.
Are we just in that one, the one that's on the board right now? No, not that one. Yeah. Are we just assuming that a is just a number?
Yes.
Like it would be
Any
in this scenario, it's e. Okay.
Maybe.
All right, let's try this one. So if I wanted the derivative of y equals the natural log of x cubed plus 1. So my derivative is, since it's a natural log, I can do just 1 over the argument. If it was any other log, I'd have to take it times the natural log of the base on the bottom. But
Or the inside.
I have to do derivative of the inside for chain rule, so that would be 3x squared. So our derivative is 3x squared over x cubed plus 1.
This is scarily easy.
I know, isn't it? After all the work you've been
Is
doing.
it always gonna be this easy? Oh wow. Okay.
Oh, yeah, it is.
Okay.
It's
Let's look at this one.
Oh, this is UI. I'm kidding. I'm joke. I am joke.
Oh, I get it.
Alright. So it's a natural log. So the derivative is just 1 over the argument, which is sine x. Derivative of sine x is. So you-
Cosine over sine x. Oh my gosh.
Oh my gosh, it's cotangent.
Tangent.
Equals. Or.
Wait, but cotangent x equals.
1 over tangent. No.
Well, tangent equals 1 over sine over cosine.
Not necessarily. I mean, if it's just like a sine, cosine, a basic one in there.
Oh goodness. And
Alright.
x.
A square root is the same thing as what?
1/2 power.
Alright, so our derivative. What do we have to do?
Chain rule.
So x when it comes down, inside stays the same.
Oh.
Yeah, I did that wrong.
Subtract 1 from the power times derivative of the inside. What's the derivative of natural log x?
1 over x.
We could clean this up as much as we wanted. The 2 and the x are on the bottom. What's a negative 1/2 mean? It would be on,
On the bottom.
so it's 1 over 2x square root natural log x.
On the homework and like test wise and stuff, are you going to want us to turn our fraction exponents back into radicals?
No?
Equivalent.
Right. Are we gonna do like prime squared?
Why would you ask?
That would just be a second derivative.
Oh, okay, never mind. I thought he was unlocking something we weren't ready yet.
Unlocking a.
Carson does all the side quests before he does the main quest, so then when he gets to the main quest, he has all like the armor and everything read out. Well, on base 10. What did he say?
Oh my god, it's like what did you say? It's the little sage animation. You would understand. It's like
Alright, repeat person.
yeah, we're all watching now.
I'll do it later. I'll do it tomorrow.
Yeah,
At this
at
exact
home.
Isn't it just like this when you like spam the animation?
Alright, so derivative of a log base 10.
Uh-oh.
So what's different if it's not a natural log?
Then we.
It won't cancel.
We gotta
Oh,
do
we
the
gotta change it
set
to the.
10 equal to
Yeah,
y.
10 to the y.
Oh, sorry,
equals
10 to the y
2
equals.
plus sine of
We
x.
don't have to. I mean, we could.
Okay.
It's the
Oh,
same.
my bad.
Remember the very first slide? The difference is it's 1 over x times the natural log of base in the denominator. So, here, if I'm doing this one,
Is-
it would be 1 over the argument times the natural log of the base.
Oh, that's all.
So x was the argument.
Can I hit explain? Can you explain?
What?
No, I don't want to.
It's not natural log, so my denominator includes the natural log of the base. Just like when we did derivatives, and it wasn't an e. You know, they had an extra natural log of the base with it. Times, we have to do chain rule, derivative of the inside. So derivative of 2 is 0 plus derivative of sine.
Cosine x.
So we get cosine x over 2 plus sine x, natural log 10.
So, if you did
to.
It doesn't matter.
Okay, I'm just gonna put it.
Do you want me to look at it, Kristen?
I just the
Why don't you guys try this one?
white bit in the
Best for last. Start. So, derivative of a log is 1 over the argument.
Interesting.
Okay? Times the natural log of the base, but it's natural log of b, so I don't need to worry about that. However, because the argument is not a plain x, we have to do chain rule. So times derivative of the inside. I am going to treat this as x plus 1 over x minus 2 to the 1/2. Now you could have made it a negative 1/2 and then product rule. I'm just going to keep it like this and do quotient rule. So that's low. D high, derivative of x plus 1, 1. Minus high, D low. So exponent comes down, x minus 2 stays, subtract 1 from the power, times derivative of the inside, which is just 1. Over low, squared, negative 1/2 squared, which just gives me an x minus 2 to the first. Okay, let's clean this up. 1 over a fraction, you can flip and multiply, so it would make it x minus 2 to the 1/2 over x plus 1. Okay, this is x minus 2 to the 1/2 minus 1/2 x plus 1 x minus 2 negative 1/2. Okay, I am cleaning up at this point. So, how could I get rid of this 1/2?
Bring the 2 to the denominator.
Yeah, so we multiply 2 to every term. Okay. Now if I distribute, 2 times x minus 2 to the 1/2 times x minus 2 to the 1/2 is 2 times x minus 2. Minus, what happens x minus 2 to the 1/2 and the negative 1/2?
Becomes 1.
So we set that x plus 1 over 2 x plus 1 x minus 2.
What happened to your other x minus 2 with the negative 1/2?
I multiplied it with this one.
Oh, a negative.
Negative 1/2 plus 1/2 is 0.
And it's a 1. Gotcha.
Alright, so if I just distribute this as 2x minus 4 minus x minus 1, so we get x minus 5 over 2 x plus 1 x minus 2. And that's it.
Yeah, I did not do that right. The
Wait,
first
so
round.
how did we?
Oh,
Oh my
that's
gosh.
so much.
8 problems.